Very good afternoon, friends. Very good afternoon, my dear friends. I hope you all are safe and you're staying well, and you are also keeping the social distance. Also keeping the same social distance as per the guideline of the government. And so I just request you to keep yourself away from the person. Okay. So now we are moving on to our topic, and before moving on to the topic, I would just like to tell you that is whatever the topics I have covered in the last lectures, and I would again like to request you that is the topic which I had covered in the first lecture was topic which I had covered. So what are the topics which I covered? Angle modulation first, angle modulation 2, angle modulation 3, angle modulation 4, and NBPM and NBFM generation. So in these topics I have covered. So in these lectures I have covered rather what I have covered. I have covered what is angle modulation, how many types of angle modulations are there, what is phase modulation, frequency modulations, right? So these are the things which I have covered. So I am again requesting you to watch my previous lecture which I have uploaded, okay, in group earlier. So just watch those lectures so that for the better understanding of those lectures and also for the today's lecture, you need to also go through those lectures so that you could understand the today's lecture. So now I'm coming on to my lecture. Okay, so today I'm going to take the example that is a single tone frequency modulation is there. Single tone frequency modulation. Single tone frequency modulation. So this is the topic of our discussion today. So single tone frequency modulation. So what I am going to do here, I will take a single tone frequency modulated signal and it is expressed by some expression, and then after that I am going to find the now, and after that we'll be having a here will be a question, that is we will be having a carrier. What is a carrier? A carrier is A cos omega ct. We are taking the carrier A cos omega ct, which is a single tone modulating signal, frequency modulated by modulating signal ft is equal to E m cos omega m t. Okay, so we have a carrier which is frequency modulated by modulating signal ft is equal to em cos omega mt, and this which is a single tone frequency modulated signal. Just wait a minute. The question should be like this. That is a carrier of cos omega ct, frequency modulated by modulating signal ft em cos omega mt, and this is what, which is a single tone modulating signal, single tone modulating signal. So here we are solving the question, that is we have a carrier which is frequency modulated by a modulating signal ft is equal to em cos omega mt, and which is single tone modulating signal. So what we have to find here, we have to find two things. We have to find the expression. For what? First thing for FM wave, okay, and second for NBFM, right? So here is the question, that is a single. We are discussing the single tone frequency modulation. Here what is the question? A carrier A cos omega ct, frequency modulated by modulating signal ft is equal to em cos omega mt, which is a single tone modulating signal. So we have to find the two expressions. One is the expression for FM wave and second one is the expression for NBFM wave. Okay, so you have to find these two expressions, right? So this is the question. So how I'm going to do is, I will solve these two parts separately. I guess all of you have noted down all the question which I have dictated right now. That is a carrier cos omega ct, frequency modulated by modulating signal ft em cos omega mt, single tone, which is a single tone modulating signal. We have to find the expression for it. Two waves, that is for FM wave and for NBFM wave. Now I am going to solve it like this. Now I am erasing it. That is I am going. So first of all, I have to find the expression for FM wave. So first part I am going to part, that is for FM wave. I have to find the expression for FM wave. How the first part I am going to solve, that is how I can find the expression for FM wave. Now for FM wave, the two things will be needed. One is the instantaneous frequency, second one is the phase angle, right? So first of all, I need to find the instantaneous frequency, and I have to find this. As I have to find the instantaneous frequency, the instantaneous frequency can be found with the help of the expression of instantaneous frequency in the case of FM wave. So the instantaneous frequency can be found with the help of expression, with the help of equation which I am writing below, right? Okay, given below the equation which I am going to write now, right? So what is the equation? That is omega equal to omega c plus kf ft. This is the equation which I already found. Let's name this equation as 23. It's equation number 23. So first of all, you have to find the value, find the expression for instantaneous frequency, right? And for that purpose, first of all, I have to write the equation for the instantaneous frequency, which is omega equal to omega c plus kf ft. Let's name this expression as 23. Now, so now I move ahead. That is, so what I'm going to do, that is omega a is there, omega c is there. Now in place of kf is there, in place of ft, what is the ft here? Ft is a single tone modulating signal, and the value of this ft is em cos omega mt. So what I have done here, I put the value of ft, okay, from the questions. In the question it is given there, the value, we are taking the single tone modulating signal, and the value of this single tone modulating signal is em cos omega mt. And let's name this expression as 24. Let's name this expression as 24. So omega equal to omega c plus kf em cos omega mt. Let's name this expression as 24. Here this kf em, that is this kf em is what? We already found this kf em. This kf em is nothing but it is the delta omega, and it is the value of the frequency deviation, okay. So this kfm is the thing, it's representing the value of frequency deviation delta omega. So what I will do now, now I can erase the part which is there. I can erase it now. So I am erasing it. Now what I have to do, I have to place delta omega in this expression. That is, in place of this kfm, I will have to put the value of delta. I have to put the value delta omega, because delta omega equal to kfem, and kfm is what? It is the frequency deviation. So now your equation will become omega equal to omega c plus kfem. In place of kfem, I will write delta omega cos omega mt. Let's name this expression as equation number 25. Let's name this expression as equation number 25. Now, what I have to, now the one thing I have calculated, that is the instantaneous frequency. Now I have to get the value of phase angle. In order to get the value of phase angle, what I have to do, I have to integrate the equation number 25. Because of integrating instantaneous frequency, I will get the expression for the phase angle. Now, for phase angle, what I have to do, integrate equation 25, which is equation for what? Instantaneous frequency. So let's do it. That is here I am going to differentiate, that is this yes, integrate it, that is this psi I have to find out the psi I. So what is psi I? This psi I is nothing but integration of omega I dt. So now what I am going to do, I will just integrate this expression so that I could get the value of phase angle. I want to get the value of phase angle. So what I have done here, omega I equal to omega c plus delta omega cos omega mt, and how I got this expression, that is in place of kfem I put the value of kfem, which is delta omega. Delta omega is nothing but it is the frequency deviation. Now I want to get the value of phase angle. I want to get the value of phase angle. Now for getting the value of phase angle, I will integrate equation number 25, which is the expression for instantaneous frequency. Now that's what I am doing right here now. So here I will write this omega c plus delta omega cos omega mt, right, and dt. I am integrating it with respect to t, right. So what I will get here, I will get omega c t plus delta omega upon omega m sine omega m t, right. So this is the expression which I will get after integrating this psi omega I. So what is omega I? Omega I is the expression for instantaneous frequency, and after integrating this instantaneous frequency, I will get the value of phase angle. So let's name this expression as equation number 26. This is equation number 26. Now I got the value of instantaneous frequency. Now I got the value of psi I. Now with the help of this, I can find the expression for the FM wave. Now, so what I am going to do now, I have to find the expression for FM wave. Now, what is the expression for this FM wave? Psi FMT is what? Is equal to A cos psi I. Now, let's name this expression as equation number 27. Now, as you can clearly see that now I got the value of psi I, so I have to only put the value of psi I, so that I will get the expression for an FM wave. Now, is equal to A cos psi is equal to, which is equation number 27. Now I want to get the expression for an FM wave, so I'll have to put the value of psi I. So it comes out to be psi FMT. Just wait, psi FMT is equal to what? The expression which I have written earlier, what was there? It was first of all, I will just skipping some things, so I will just try to correct it. That is what I got. I got psi I is equal to omega ct, right, plus delta omega, right, delta omega. Then what I have got, delta omega and sine omega mt. The expression which I got, and omega. I was forgetting something. I was just I forget to tell you one thing. That is this expression, this part is what? This is known as the modulation index MF here. This is what? This is the modulation index. This is what? This is the modulation index in the case of FM. Modulation index in the case of MF. And so what is this? This quantity, this whole quantity, in place of this whole quantity, I will write that expression again, right? Why so? Because I skipped that term. So omega ct plus delta omega upon omega m sin omega mt. So delta omega upon omega m equal to mf, which is a modulation index. So what is modulation index in the case of FM? It is the ratio of frequency deviation and the modulating frequency omega m. So modulation index mf in the case of FM is nothing but it is the ratio of frequency deviation and the modulating frequency omega m, right? So now I can write this expression as, now I will write this expression, that is psi I is equal to omega ct plus delta omega of omega m. In place of this I will write mf, right, sin omega mt, and I will say this expression is 27. This is equation number 27, not that one. This one is the equation number 27. So this psi I is there. Now I have found the value of psi correctly. That is, here I forgot to include this mf. Mf is nothing but it is the modulation index. Now I can move ahead. I can find the value of phi fmt, which is the expression for an FM wave. So you know that I will write it. That is psi fmt T expression for it is equal to A cos psi I. Now name this expression as equation number 28. Now what I will do, I will put the value of psi I here, so that I could get the expression for this FM wave. So now I will erase the part, this part I will erase, and I will leave that part as it is now. So now I will put the value here, that is psi FMT is equal to what? Psi FMT is equal to A cos is as it is now. In place of psi I will put this value, that is omega CT plus MF sin omega mt, sin omega mt, and this is the expression for an FM wave. This is an expression for FM wave. This is equation number 29. This equation number 29 is nothing but is an expression for an FM wave. This is an expression for FM wave. Now the thing which I am going to tell you, that is this here the frequency deviation, this modulation index, here this expression is showing you something, that is I forget to write something here, that is this is omega CT. I forget to write omega CT plus, now this plus sign. I will again write this expression so that you could see it very clearly and you could understand it also. That is I will write A cos is there, and omega CT, now I can clearly see this, plus MF. Now you can clearly see this sin omega mt. Now you can see this clearly. You can see this expression very clearly now. So this is equation number 29. This is equation number 29. So now this equation 29 is telling us something, that is here we can see the value of phase deviation, which is denoted by delta theta. What is frequency deviation? So this phase deviation, not frequency deviation, because frequency deviation we have already discussed. So here what is phase deviation? Phase deviation is the maximum change in the from average value omega CT is known as what? Phase deviation, and it is denoted by delta theta in MF radians, right? So maximum change in phase angle from the average value omega CT is known as the phase deviation denoted by delta theta in MF radians. So this MF is this delta theta is nothing. This delta theta is MF radians. Now there is a relation between this delta theta and the frequency deviation. So in order to get that relation, what I have to do, I have to put the value of this MF. MF is what? MF is equal to delta omega upon omega m, right? Is equal to MF. So you can clearly see here that this frequency deviation, this phase deviation is directly proportional to the frequency deviation. This is the relation which is showing, which is the relation between the phase deviation and the frequency deviation. So what I have found the expression for the FM wave, which is given by phi mt is equal to A cos omega CT plus MF sin omega mt, and it's equation number 29. So with this equation tells us that is the maximum deviation from the average value omega CT, not average value, from center, not average value, from center omega CT is known as the phase deviation, is noted by delta theta in MF radians. So delta theta is MF radians, and delta, if you want to find the relation between the phase deviation and frequency deviation, so we have to put the value of the MF, which is the modulation index. So when I will put the value of modulation index delta omega upon omega m, so I will get the relation between these two things, that is these two things. This is the relation, that is it is directly proportional to the frequency modulation. So the phase deviation is directly proportional to the frequency deviation. Get it? Now I am moving on to the next part of our our question, that is till now what I have done, I have found the expression for an FM wave, which is equal to phi FM t is equal to a cos omega ct plus 1 sin omega m t. Now I am moving to what is the next part, that is NBFM. NBFM. It's a little NBFM. NBFM, first of all I have to write the expression for NBFM t, that is psi FM t for NBFM is given by a cos omega ct right now, then minus k, yes, kf gt sin omega ct. This is the expression for what? This is the expression for an NBFM. Now this gt is what? This is, let's say this is equation number 31. Now gt is what? gt is the integral of ft. gt is equal to integral of ft. Now what is ft here? ft is the integral of em cos omega mt. Em cos omega mt. So in place of em cos omega mt, what I am going to write? I will write em upon omega m sin omega mt. Sin omega. This is the equation number 32. Now simply what I have to do, I have to put the value here. I have to put the value here. I will put the value. So this kf em upon omega m, whatever it will represent. So now I will put the value here in this expression 31. Putting this value in the equation 31, that is phi fmt is equal to what? A cos omega ct will be as it is. Now what I am going to do, I will put the value, that is I will put the value of gt here in this expression number 31. So what I will get, minus in place of kf will be as it is, kf em upon omega, right? Sin omega ct. Omega. Now this kf em upon omega m is what? Mf. This kf em upon omega m is equal to, yes, mf. It's equal to mf. So this is equation number 33. We know that value of this mf is equal to kf em upon omega m. So what I am going to do now, I will, in place of this this kf em upon omega m, I will write mf. So now what I am going to write, I will write this, which is the final expression for fm, that is psi fmt is equal to a cos omega ct, minus mf sin omega ct. Sin omega ct.
T.
This is an expression for NBFM. Question number 30. This is the expression for NBFM. So that's how we can find the value of what? NBFM. That's how we can get the expression for an NBFM wave. So what we have found today? Today we have found the expression for of frequency for expression of for FM and NBFM for a single tone modulating signal. Okay, so that's it for today, and just please follow my next lecture, whatever, and So I would again like to tell you that is please watch my previous lecture so that you could understand this topic very well. Okay. बंद करो इसको।